Okay, we are correcting section 2.3, which is operations of rational numbers in fraction form. So we're following along here with our questions out. Anything that we need to add, we will do so. So the first question says estimate and calculate. This is a tricky question to estimate. But if I'm thinking about 4/5 divided into 5/5, I want to think money. So I'm going to do a quick check, divided into, I can't even figure it out. So I don't know what 5/6 is as a decimal estimation-wise. So I'm okay if you don't estimate this question. So I'm just going to go basically right to the algorithm. We said before, the easiest way is to keep your first fraction, change to multiplication, and we talked about using the reciprocal of your second fraction. Once we have that, multiply your numerators and multiply your denominators, you end up with a final answer of positive 24/25. When we do B, C, D, E, and F, we can estimate as long as it's not division of fractions. We're going to just do it like this. 3 times 2 will be approximately, my answer should be approximately positive 6. We know that when we multiply or work with any mixed fractions, your handsome math teacher said, make sure you change all of your mixed fractions to improper. Once you have that, you could check for cross reduction. Smart people would. If you were a smart person, you would do this. You divide both of those numbers by 2 and get this. But if you're developing that cross reduction skill and you didn't do it yet, you will multiply your numerators to get 70, multiply your denominators to get 12. How many 12s in 70? There is exactly 5 of them. That's 60. And 10 twelfths, which in lowest terms is 5 and 5/6 as your final answer, which is pretty close to my estimation of positive 6. Next question is multiplication. This time we actually have a grade 9 question where there's positive, negative. Same algorithm, same process, just you have to use your integer signs. If I cross reduce, I did this, divided both of those terms by 2, and I ended up with 1/20th as my answer, or since it's a positive multiplied by a negative 1/20th. Next question, keep your first fraction, change to multiplication, use the reciprocal of the second. Notice how my negative symbol is still in the numerator. Cross reduce, great idea. If you don't, it ain't no thing. You got 45/40, which is a mixed or an improper fraction. Change it to mixed, you get 1 5/40, which is not lowest terms. 1 1/8. Since both 5 and 40 are divisible by 5, you have 1 1/8 as your final answer. And your last question, last 2 questions from question number, is this 5? 7, okay. Multiply, going to keep my numerator up here, going to change 5 1/3 to 16/3. Going to multiply the numerators if I needed to. If I was smart, I'd do this, so much easier. But if you didn't do that, I understand, it's okay. You could also do the other ways, right? Negative 48/24, which is okay, because when I wrote that down, I know what that is in lowest terms anyway, don't I? Because you's a smart cookie. The answer is just a solid -2. And your final answer, final question, 1/10 multiplied by the reciprocal. Multiply your numerators, multiply your denominators. Is that lowest terms? No, because both are divisible by 2. You get -4/15 as your final answer in lowest terms. Question number 9 says Lori owed her mama $39. Lori paid back 1/3 of the debt, then paid back 1/4 of the remaining debt. How much does she still owe her mother? So for question 9, I always want you to try and draw it if possible. Now, since she owes $39, the easiest way here is to make this rectangle represent her debt. Okay? That's all of her debt. If we wanted to put a negative symbol, more appropriate because it's owing $39. Did I do the quarter first? Thank you. So this time, she's going to pay back 1/3, which I think I put my line, I think my line should be probably there instead, shouldn't it? I'm keeping this proportional to the rectangle size. She's going to pay back 1/3. So I don't know what 1/3 of this is, but here's what I'm going to do. She's going to write down, I'm going to write down in words, 1/3 of the debt. Oh, a third of the debt. And when I think about this, I can translate that English sentence to mathematics. A third of is always multiplication. And if I think about what the debt was, it's $39. So that one sentence, a third of the debt, can be translated to a third times 39. When you have a whole number, it's easiest to sometimes write it as a fraction over 1 because then your algorithm is consistent. Multiply your numerators, you get 39. Multiply your denominators, you get 3. And finally, since it's dollars, we don't want to keep it as, technically as this. How much money did she pay back? She paid back a third of 39, which if we think about what that is $13. So therefore, she paid back $13 with her first payment, which means her new debt is the $39 minus the 13. Her debt is now $26. And this repeats one more time when we go to say the quarter. So this time she's going to pay back a quarter of that. It's probably not, that's probably closer to right there. A quarter of the 26. So again, a quarter of the 26 will be 26 over 4, which is 13 over 2, which if you do some math on that, you probably don't even need to grab a calculator. Half of 10 is 5, half of 3 is 1.5. So she paid back $6.50. Therefore, since the debt was 26, take away the $6.50 that she paid back. Therefore, after her 2 payments, she still owes. Therefore, she still owes $19.50. Question number 10 is a continuation similar to the other one. The only thing we said was we changed this to new, correct? To the new amount of baseboard. Or the remaining, sorry, remaining. The remaining amount of baseboard. Okay. We changed this word to remaining because I think there was a misprint in the book. So we're going to use this. So same methodology as the last one. So a carpenter has 64, this is his total amount of baseboard. He has 64 meters of baseboard. He installs half of the baseboard in one room. So if we do half of 64, I think everybody can do this without too much. He installs 32 meters in one room. Okay? Now, how much baseboard does he have left? New rectangle. This is now no longer 64, this is 32. How much of the remaining baseboard does he install in the other room? He installs 3/5 of it, which if you do it accurately would be less than half. So my last question is, what is 3/5 of 32? Right? Because I want to know how much he installed. What's that? More than, oh yeah, but I want to put my, yeah, okay. I went backwards. I want this to be less than half, yeah. Then we have multiplier numerators, 96 over 5. Take my calculator, reduce this, or I can actually use it as a mixed fraction. It should be 19, because 20 would be 100, and 4/5. So you have 19 and 1/5, that's 96 as a mixed fraction, or 19.2 meters of baseboard. So either one's fine. Therefore, he has 19 1/5 meters left, or 19.2 meters left of baseboard. Okay. And I know baseboard. I'll just call it baseboard.
I thought that was what
he installed 3/5. Oh my God, you're right. Sophie, thank God you're here. So I made the mistake. Sophie's on it. She's paying attention. The rest of you were all daydreaming. So remember, he had 32, so you got to go 32. Take away the 19.2 to the used. It's 12 plus 0.8, 12.8. So therefore, he has 12.8 meters of baseboard left. Our last question, so you should have been actively listening as we went through that. I know. Boris has 2.5 times as much cash as Anna. Charlie has 3/4 as much cash as Anna. And Anna has $25.60 in cash. How much cash do the 3 people have altogether? So this is a little tricky. But we're going to organize it very nicely with just the letters A, B, and C. This is going to be my graphic organizer. I'm not going to use a picture as much as I'm going to use a graphic organizer. Of the A, the B, or the C, which one do I know exactly how much it is? Anna. Anna, when I put it down in here, has $25.60. I know how much she has because they tells me. But then when I look at Charlie, or let's look at Boris first. What does Boris have? 2.5 times as much as Anna. So mathematically, I'm going to organize it that way. Boris has 2.5 times as much as Anna, or 2.5 times 25.60. And Charlie, or the C, has 3/4 as much of the amount that Anna has. So it's going to look like that. Okay. So now I've organized my data. I have all my math down. All I have to do now is figure out what this is. Now, sensibly speaking, would anybody anywhere use fractions for this question? For this question? No. Ain't nobody going to use it. So you're going to then say, correct? And for 3/4, Mike, remind me what 3/4 is as a decimal again? Correct. So we're going to use 3/4 of 25.60. We're going to get two answers here. I think I can do this in my head. Let's see if I can do it. 51.20 and 12.50, 12.80. It should be $64 even, I think. All right, I better take a calculator because I'm not that proud of my math ability. It is $64. So Boris has $64. And Charlie, let's see, 12.30, 6.15, 18.45. I think. Let's see if that's right. My God, if I bat 2 for 2 today, that's pretty impressive. No, I'm off. 19.20. Oh well. It was fun while it lasted. 19.20. And Riley, last question goes to you. In order to answer A, what do I have to do? What's that? If I'm doing A, how do I answer A? Add them together. So A plus B plus C will be the sum of them, or 25.60 plus $64 plus 19.20. If you want to try practicing good mental math skills, let's go 20. I'm just going to put a line through the 2. 20 and 60 and 10. What's 20, 60, and 10 make? 90, right? 99, 103, 108, 108.80. Therefore, they have $108.80. The last question is so simple it's not even funny. It says, how much more cash does Boris have than Charlie? Jojo, how do I find out how much more money Boris has than Charlie? What operation is necessary? Yes. So $64, take away 19.20. Add on to this until I get this. So I'm going to put 80 cents down. I'm at $20. From $20 to $64 is another 44 bucks. So therefore, for B, he has $44.80 more. And that's your answer.